Good morning, students. In this lecture, we will derive the minimum velocity along a vertical cylindrical wheel of death. We are going to find out whale of death, that is called मौत का कुआं. Most of the students have seen in Mela, Jatra fair, that one vehicle is moving along the what? Vertical cylindrical well of death. Students, in this diagram, a vertical cylindrical wall of radius. You can see the radius of a vertical cylindrical wall is what? Smaller. Inside that vertical cylindrical wall, vehicle will what? Travel like this. You can see like this. Okay, you can see. I say along the vertical cylindrical wall. When vehicle is what? Driven in a horizontal circles, you will see it's a horizontal circle dotted part. Now that vehicle should be balanced. So we observe that when vehicle is what? Traveling along the vertical cylindrical wall, it is horizontal, but its own weight is always in downward direction. So its mg is own weight, you can see. Since vehicle is what? Normal to that surface of the cylindrical wall, normal, that reaction is always be perpendicular to that surface. So what is and represent here? Normal reaction acting horizontally. The two forces we understood. One is its own weight, mg, vertically downward. Another is what? Horizontal normal reaction. So one more force is there, because when vehicle is what? Driven along the vertical wall of the cylinder, then it should be frictional force. So we observe that when vehicle is what? Moving along this vertical cylindrical wall, then frictional force is always in upward direction. Students, this is very important thing you have to understand or imagine. The force of static friction acting vertically upward between what? Vertical wall and what? Tires. Fs is a static friction because it has to prevent the downward slipping. You will see, you will ask students why this Fs is vertically upward. If frictional force will provides or will avoid that slipping the vehicle towards downward. That's why frictional is what? In the opposite, in a vertical direction. And we observe that its vertical force is balanced by whom? Its own weight mg. So students, first equation will be what? Fs is balanced by what? Its own weight mg. And students, what is the horizontal reaction here? N. And we know that horizontal force will always help us to perform circular motion of that vehicle along the what? Vertical cylindrical, horizontal circles, along the horizontal circles. Means horizontal reaction and provides a necessary centripetal force for that vehicle. So students, first equation we understood, Fs is balanced by mg, and this normal reaction and will provide what? Necessary centripetal force if vehicle of mass n moving along the horizontal circle with a velocity v and circle of radius r, then centripetal force is given by mv square upon r. This is equation number 1. This is equation number 2. Students, this frictional force, since it is in vertical direction and it is along the horizontal circle, so this frictional force is always be less than or equals to, we can say, coefficient of static friction multiplied by what? Normal reaction. This is basic equation we studied in what? 11th standard. So students, instead of Fs, we will put here mg, and in place of n, I will put what? Mv square upon r. Simple mathematics we are going to perform over here. You will see here, Fs is less than equals to mu s. Is very important equation that you know. Instead of Fs, I am going to replace Fs by mg, which is balanced from equation number 1. What is n here? Centripetal force. This is centripetal force. We observe the mm get cancelled. I will shift it over there. Gr upon what? Coefficient of static friction is always less than equals to v square. Means v square is greater than equals to gr upon mu s. When mu s is what? Coefficient of static friction. Students, therefore what is v mean? V mean is what? Therefore v mean is what? Is greater than or equals to gr upon mu s. So what is the minimum? Greater than equals to matlab what? That is our requirement. So what is minimum velocity along the horizontal circle of that vehicle is what? Under root of gr upon mu s. Students, you have to remember this particular formula of vehicle when moving along the horizontal circle of vertical cylindrical well of depth. Students, let us do the one numerical based on this particular formula. Let us read the question. A motorcyclist to be treated as a point mass is undertake horizontal circles inside the cylindrical wall of well of inner radius. So students, inner radius of that horizontal circle is given. The small r is what? 4 centimeter. Coefficient of static friction between tires and the well and the wall is what? 0.4. The coefficient of static friction mu s is given. How much it is? 0.4. Calculate the minimum speed. We have to find the minimum speed, as well as we need to find the frequency necessary to perform this stunt. We have to find what? Frequency, minimum frequency and min. Students, G is 9.8 every time we will take, but now here it is mentioned we have to take G equals to 10 meter per second square. So G is also given. Students, what is the formula for V mean? We know that the formula for V mean is given by under root of GR upon coefficient of static friction. So students, we have the value of G, we have the value of R, we have the value of mu. We will substitute into the formula and we can find out easily. So students, minimum velocity of the vehicle driven in vertical cylindrical wall of radius r is given by this particular formula under root of gr upon mu s. We will substitute the value. G is 10, r is 4 meter, mu s is what? 0.4. If I shift point towards right, let us do the simple mathematics. 10 multiplied by 40 upon 4. 4 10s are 100. So what is V mean, student? V mean is what? 10 meter per second. Students, now we have to find out frequency of necessary frequency to perform this stunt. So students, we know the formula for velocity. Velocity is given by what? R omega. And we know the formula for omega. What is the formula for omega? 2 pi into what? Frequency. If it is minimum, then frequency also be minimum. So from this formula, we can find minimum frequency easily. So what is minimum frequency equals to? V mean upon 2 pi r is equals to what? N minimum. So students, same formula I am going to apply over here. So N minimum is V mean upon 2 pi r. So we got the value of V mean is what? 10. 2 multiplied by pi multiplied by r. R is how much here? 4. So let us solve this particular equation. 4 2s are 8. If you can say 2 2 2 5s are 10. 5 by 4. To 5 by 4 pi revolution per second. You can find out. You put the value of pi over here and just find out. Thank you very much.